Extracting oil and gas requires maintaining continuous 24-hour operations in some of the most hostile physical environments on Earth, all while navigating extreme macroeconomic volatility. Market demand for energy doesn't follow a smooth curve. It reacts violently to rapid shifts in global commodity pricing and sudden geopolitical disruptions. These macro forces dictate aggressive physical changes on the ground. A spike in pricing triggers an immediate demand for massive drilling campaigns, while a market contraction requires the sudden decommissioning of active infrastructure. Traditional hiring models rely on linear headcount growth. They cannot absorb this intense expansion and contraction. Operating a rigid labor structure during a volatile market cycle guarantees operational failure. Understaffing during a boom introduces severe fatigue and catastrophic safety risks, while overstaffing during a bust bleeds capital through idle labor. Because workforce volatility directly dictates both production output and overhead costs, treating labor as a transactional human resources function is an unacceptable operational risk. Workforce solutions function as integrated risk control systems, coordinating human capital, operational timelines, and safety protocols across high-stakes environments. This diagram illustrates how these systems function. Every operation must simultaneously satisfy three overlapping constraints. First is labor availability. Securing specialized technical talent and transporting them to highly remote geographies presents an immense logistical hurdle. Second is the unyielding requirement for continuous operational uptime. Shutting down an active upstream rig or a downstream refinery for a staffing shortage destroys profitability. Third is the strict enforcement of safety, environmental, and labor regulations. A single compliance violation can shut down an entire site instantly. The intersection of these three circles defines the operational sweet spot. The goal here is predictability and adaptability, rather than simply filling an empty desk. Solving the volatility equation requires architecting a dynamic system that balances all three constraints simultaneously. Let's look at how that architecture is built. The first step in building this architecture involves defining the structural geometry of the labor pool to match a specific asset's risk tolerance. We can map this strategy onto a matrix defined by two axes, stability and flexibility. In the high stability quadrant sits the permanent workforce. This group includes site supervisors, engineers, and core maintenance personnel who provide critical institutional knowledge and continuous oversight. However, relying exclusively on this rigid core fails when facing a sudden drilling campaign or an intensive short-term technical intervention. Contract labor provides the necessary counterbalance. It allows operations to scale rapidly from major turnarounds without taking on long-term financial commitments. But running highly flexible, disparate groups of contractors at scale introduces its own risk. Inconsistent standards across different vendors often lead to dangerous compliance gaps on site. To solve this, managed workforce programs act as an organizational layer, unifying procurement, onboarding, and compliance under centralized oversight. This results in a comprehensive hybrid structure. It surrounds the stable, permanent core with a managed, highly flexible exterior. Deploying this precise geometry eliminates the operational errors and equipment damage caused by trying to force static labor models into dynamic production environments. Once the labor structure is defined, it must be secured. Major safety incidents in oil and gas are rarely isolated mechanical failures. They almost always originate from systemic workforce gaps, unverified technical competencies, miscommunication between disjointed teams, or severe physical fatigue. Traditional operations often treat safety as a final administrative checklist. Modern architectures embed it as a continuous pipeline designed to catch failure points before they manifest. Here is that pipeline in action. The first stage enforces strict pre-deployment training and certification verification before a worker ever steps onto the site. The second stage monitors the workforce in real time, utilizing active fatigue management schedules and tracking physiological conditions on the ground. The pipeline finishes by enforcing standardized permit-to-work protocols across all contractor types, closing the loop with strict incident feedback mechanisms. By integrating safety directly into the labor structure, operations transform compliance from a reactive, audit-driven chore into an active, real-time defense mechanism. Coordinating a hybrid labor matrix and a real-time safety pipeline simultaneously requires massive data coordination. Human oversight alone simply lacks the processing power. This diagram reveals the digital architecture required to run the system. Workforce management systems handle hyper-complex scheduling, while vendor management systems organize contractor sourcing. Digital twin systems project thousands of variables to simulate workforce deployment and asset interaction before physical execution begins. This immense data processing becomes critical when applied to the industry's most demanding contexts, remote and offshore operations. These deep water or isolated sites introduce punishing logistical constraints, including complex transportation routes, extreme geographical isolation, and severely limited access to emergency medical services. The technology stack coordinates precise rotational staffing models, like rigid 14 days on, 14 days off schedules, to mitigate these risks while keeping the asset running without a second of downtime. The technology stack acts as the central nervous system of the operation, constantly converting raw workforce data into actionable, predictive deployment strategies. The labor matrix, the safety pipeline, and the technology stack all serve a single master: asset productivity. If the skills of the deployed workforce do not perfectly match the immediate mechanical requirements of the equipment on site, the entire system fractures. This dashboard shows the metrics used to evaluate how effectively an integrated workforce solution performs. The system aims to maximize the productive labor utilization rate and increase raw productivity output. Simultaneously, it must drive down operational friction, minimizing downtime and reducing hazardous dependency on overtime. True optimization is achieved only when the deployment of human capital is perfectly synchronized with the physical maintenance and production cycles of the asset itself. The industry is rapidly advancing toward a state where these workforce systems fully converge with industrial automation and operational intelligence. Soon, static planning models will be entirely replaced by live data, triggering instant automated labor adjustments the moment a machine registers a variance. Generates a definitive strategic advantage.